Welcome to the last video of Chapter 6, which covers finding roots and zeros. This is going to be a culmination of everything we've talked about this section, or this chapter rather. We're going to do some factoring, we're going to do some synthetic division, we're going to be doing some solving, so we're putting it all together. Before we look at any examples, I want us to talk about some vocab. So if we say that a number is a zero, a root, or an x-intercept, those are all the same. So you're going to hear all three of those terms, a zero, a root, or an x-intercept, all referring to the same number. That number is also then a factor of our polynomial. So zeros, roots, factors, x-intercepts, all of them are going to be similar vocabulary. So just know when you see those, we're going to be using them interchangeably. So now let's jump in. Let's talk about the fundamental theorem of algebra. A polynomial equation with degree n has exactly n roots. Now, they are not necessarily different roots. They could be real, they could be imaginary, they could be repeated. So for example, 2x cubed minus 5x squared plus 2. Degree is always the highest power. So this equation will have 3 roots. 3 roots. Next one, highest power, 14. So this equation will have 14 roots. Now again, they could be repeated, they could be imaginary. So you won't necessarily see 14 roots on the graph, but there are 14 of them. Okay, so logically then, an even function has an even number of roots. Odd function is going to have an odd number of roots. Okay, so before we go any further, we're going to look at this theorem in practice. Looking at example A, it says state the number and type of roots. So looking at our equation, x to the 6th tells us that we are going to have 6 roots. 6 roots. Now, can we see the roots? Well, we've talked about root, solution, x-intercept. So we see 2 of them here. What does that tell us? It tells us that we have 2 real roots. If there's 6 roots total, though, we must have 4 imaginary. So then looking at B, x to the 5th, degree 5, tells us that we're going to have 5 roots. Again, a root is an x-intercept. If we look, we see 3 x-intercepts. So that tells us that we have 3 real roots. If there's 5 of them total, though, 2 of them must be imaginary. Okay, once we know the type of roots, we need to be able to find them. So that's what we're going to do on the next page. Looking at example number 2, we are finding the zeros, or finding the roots. So first thing I want us to talk about is the degree. Degree 3 tells us that we're going to have 3 zeros, or roots. We only see 1 on the graph, which leads us to believe the other 2 may be imaginary. So if they're imaginary, how do we find them? Which is a good question. Well, first thing, what is this root? It looks like it might be -2. How do we verify that? Well, we're going to ask ourselves, is that a factor of the equation? So this goes back to what we did in the previous video. Is x equals -2 a factor or a 0? Well, we're going to do synthetic division and find out. Taking our coefficients, we have 1, 2, 9, 18. First number comes down, then you're ready to multiply. Add down. So yes, this is a root or a factor or a 0. So now what we can do is take what's left. Take this here. Because we started with x cubed, this will be x squared. So we have x squared plus 0x, add 9 equals 0. And now we need to solve this. That 0x we don't really need, so this is x squared plus 9 equals 0. So that's good. So solving for x squared, we take a square root. Don't forget plus or minus, and then 3i. So if we are looking for all of our solutions, we have that -2 from the graph and plus or minus 3i. 3 solutions. We knew that that's what we were going to get. Remember, we said that at the very beginning of the problem. So always make sure that the answers that you get go along with what you thought you should get. So we thought we would get 3 zeros, 1 real, 2 imaginary, and that is in fact what we got. I know that's confusing, so we're going to look at another example together. Example 3. So what we can see here, x to the 4th tells us that we're going to have 4 roots. We can see 2 of them are real. If we need 4 total, though, that means 2 of them are going to be imaginary. It looks like this first root might be at -2. Looks like the second one might be at +2. How do we verify that those are the correct roots? Well, let's start with the -2. We're going to do the synthetic division. We notice we're not missing any terms from our initial polynomial. They're in order, so let's bring down those coefficients. First number comes down, we multiply, then we add. We got a remainder of 0, so yes, this is the correct root or solution or 0, whatever term you want to use. Okay, that's good. Now, if we started with x to the 4th, this is going to be x cubed. So we have x cubed minus 8x squared plus 22x minus 20. Now, do we know how to solve that? No. We know how to solve squares, quadratics, but x to the cube we can't solve. So we need to keep going. What we're going to do now is verify that x equals 2 is a root. Don't go back to the very original problem. You're going to continue with what we got previously. So now, if we do synthetic division with 2, bring down our constants, or our coefficients. So bring down our 1, multiply, then add. So yes, we got another root again. That's great. So what we've done so far is we have verified that 2 and -2 are roots. So those are our real roots. We still need to find the 2 imaginary. Now, when we did synthetic division for the second time, we started with x cubed, which means this is x squared. So we have x squared minus 6x plus 10 is equal to 0, since we're solving. Now we need to solve this. So it's a quadratic, we can factor, or we can try. We can use the quadratic formula. This doesn't factor, so I am going to need to use the quadratic formula. I'm going to do that over here. So I get the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So this is going to be 6 plus or minus. Underneath the square root, I have 36 minus 40, which is -4. Okay, be careful here. I'm not ready to divide by 2 yet. Not ready to divide by 2 yet. I need to actually take the square root. So square root of -4 is 2i. So now I get 3 plus or minus I. Now, my work is kind of all over the place here. I don't want to have to be searching your work to find what your answers are. So let's bring all of them together. From the graph, we got -2 and +2. We also got 3 plus or minus I. So those are our solutions, our roots, our zeros, whatever term you want to use. Please make sure that that checks with our beginning thoughts. Yes, we got 4 roots. Yes, 2 of them are real and 2 of them are imaginary. I know this is a confusing process, so there is an extra example at the very end of the video going through this again. Before we get to that extra example, though, there is one more topic or one more theorem we need to talk about. So please flip the page. Last thing we need to talk about is going backwards. What happens if you have the roots and you want to write the equation? So you have the solutions, you want to write the equation. One thing we need to know before we do that is what's called the complex conjugates theorem. If a plus bi is a zero of the polynomial function, then a minus bi is also a zero. Okay, what does this mean to us, or why is this important? What's really important here is that imaginary or complex roots always come in pairs. You're never going to have one complex root. There will always be pairs. You'll have 0, 2, 4, 6. You will never have an odd number of imaginary roots. Okay, so example 4a is something that you have seen before. It's writing a polynomial equation given the solutions. So this is something that we did first semester. I know that x equals 4 is an answer. X plus 3, not x plus 3. X equals negative 3. And x equals 5 are all solutions. What I want to do is I want to make them factors. So if I move that 4 over, I get x minus 4 equals 0. I add 3, and I subtract 5. So hopefully you remember doing this. This now gives us our factors. So we have x minus 4, x plus 3, and x minus 5. Now, I want this to be in terms of standard form. So I don't want the factored form. I want it in standard form. So we do need to multiply this out. I'm going to start here. We've talked about some of you like to FOIL. I like to do the box. Doesn't matter either way. So we get x squared, 3x, negative 4x, and negative 12. Combining like terms, I get x squared minus x minus 12. Don't forget you still have that x minus 5. So there is another multiplication we need to do. Again, I like the box or the table. If you want to factor, or not factor, if you want to FOIL or do the arcs, you can. So this is x squared minus x minus 12. So we get x cubed, negative x squared, negative 12x, negative 5x squared, positive 5x, and positive 60. We're almost done. Stick with me. Combining like terms, I have x cubed. Here are my x squareds. Then I have negative 7x plus 60. Do not leave your answer like this. Your answer needs to be an equation. An equation. So we set equal to 0. And that is our answer. So that's something that you've seen before. Example B is one where it gets a little bit more complicated. In this case, we have an imaginary root. We talked about 2 minutes ago, you never have one imaginary root. They will always have a pair. So we need to figure out what is the conjugate of 3i. Well, that's really 0 plus 3i. Conjugate of that then is 0 minus 3i. So our solutions are really 3i, negative 3i, and 1. Okay, setting equal. I get x equals 3i, x equals negative 3i, and x equals 1. So I get x minus 3i, x plus 3i, and x minus 1. So that is my whole equation. I need to multiply out though, so I'm going to erase some of this so that I have some more room. Okay, I'm going to help you out a little bit more and then have you all finish the problem. Let's be honest, nobody likes I, so let's get rid of I first. We're going to start by multiplying these two. So we have x squared, negative 3ix, positive 3ix, and negative 9I squared. Now look, what's really nice, these cancel. Here, remember that I squared is negative 1. So that's really negative 9 times negative 1, which is 9. So we get x squared plus 9. Bringing down our other factor. Okay, and then we need to multiply this out. This is where I'm going to leave you. It is now your responsibility to finish this problem. Before you turn your notes in, make sure that this problem is complete. There are 2 extra examples. Please feel free to stay on with me to go over 2 extra examples to make sure you understand this material well. Okay, so let's look at extra example number 5. First thing we want to know, x to the third tells us that we're going to have 3 roots or solutions or zeros. We see one of them on the graph, so we have 1 real, which means 2 of them need to be imaginary. Again, that makes sense. The imaginaries come in pairs. This looks like it's x equals negative 2. How can we verify that? Well, let's do our synthetic division. Now be careful here. We have 1x cubed. We're missing x squared though, so don't forget that 0. 6x and 20. First number comes down, then you're ready to multiply. Again, always remember that you're adding. 0 is what we wanted. That tells us that negative 2 is in fact our root. If we didn't get 0, one of 2 things happened. Either we made a mistake in our synthetic division, or that's not really the 0. If our equation started with x cubed, this is going to be x squared. So we have x squared minus 2x plus 10 equals 0. Okay, can I factor this? Are there 2 numbers that multiply to 10 and add to negative 2? No. So we're going to have to do quadratic formula. We get b plus or minus the square root of b squared minus 4ac all over 2a. That square root, I get 4 minus 40, which is negative 36. Okay, be careful here. Do not divide by 2 yet. We are not ready for that yet. Simplify the square root first. Square root of negative 36 is 6i. Dividing everything by 2, we get 1 plus or minus 3i. As we've talked about, our work here is all over the place. It's hard to follow. So please write all of your answers in one spot. From the graph, we got negative 2, and then we got 1 plus or minus 3i. Let's ask ourselves, is that what we thought was going to happen, or what should have happened? Did we get 3 roots? Yes, we did. Is 1 real and 2 imaginary? Yes. So our answer checks out. Example number 6. In this one, we are going to be finding the equation given the roots. So again, this 4i, that's really 0 plus 4i. We talked about imaginary roots always come in pairs. You're never going to have one of them. The conjugate of this then is 0 minus 4i. So really, our roots are negative 4i, positive 4i, and 2. So we get x equals negative 4i, x equals positive 4i, and x equals 2. We move everything to the same side to give us those factors. If I add 4i, I get x plus 4i. Middle equation, I'm going to subtract that 4i. Last equation, I'm going to subtract 2. Okay, we talked about in the example before this, we want to get rid of those i's first, so we're going to start by multiplying these two. So we get x plus 4i, x minus 4i, so this is x squared, 4ix, negative 4ix, and negative 16i squared. Like before, and this should make sense, when we multiply those conjugates, the i's should cancel. If you remember, that happened in chapter 5, when we were rationalizing the denominator. we would multiply by the conjugate to get rid of the I. Remember that I squared, though, is -1. So this is x squared plus 16 times x minus 2. This one, I don't think I have enough room to draw the box, so I'm just going to do my arcs. X squared times x is x cubed. X squared times 2 is -2x squared. I have 16 times x, 16 times -2. Please do not leave your answer like this. We know our answer needs to be an equation. So you need to set this equal to 0. Answer should be an equation, not an expression. Hopefully that helped solidify what we did in this video. If you have any questions, as always, write down your questions, come to office hours, ask during class, or send me an email. I'll see you in class.